Hello everybody, today we'll continue with our interesting study about motion. And basically, we'll learn some important information about Newton's 3 laws of motion. So let's get ready to start. Imagine that you are playing baseball. The pitch comes in and crack, you hit the ball hard. But instead of flying off, the ball just drops to the ground. Is that normal? You would probably say no. You know that force and motion are related. In 1886, Sir Isaac Newton explained the relationship between force and the motion of an object with his 3 laws of motion. Newton's first law of motion states that an object at rest remains at rest and an object in motion remains in motion at a constant speed and in a straight line, unless an unbalanced force acts on it. In order to understand this first law much better, we have to divide it in 2 parts. Firstly, we'll analyze the part that refers to the objects at rest. An object at rest is not moving, it's said to be at rest. A chair on the floor, a golf ball on a tee are examples of objects at rest. Or the walls, or even you when you are sitting. Newton's first law of motion says that an object that is at rest will continue motionless until an external force acts on it. On the other hand, an object that is in motion will continue in the same way, in motion, unless a force acts on it, or stops it, or makes it slow down. Of course, you must have thought about the friction as a force that opposes motion and the one that stops or makes an object slower. And okay, you're right. There's another relationship. It is between inertia and the first law of motion. But first, let's define what inertia is. Inertia is a tendency of all objects to resist any change in motion. Now, let's explain the relation that inertia has with the first law of motion. For example, because of inertia, you fall forward on a bus when the bus driver stops or reduces the speed. Some objects are more difficult to move than others. The explanation for this to happen is that these objects have more mass. So the explanation is, when an object has a large mass, it has more inertia, or it will be more difficult to experience a change in its motion or to move it. Newton's second law of motion states that the acceleration of an object depends on the mass and on the force that it is applied on it. Newton's second law of motion describes the motion of an object when an unbalanced force acts on the object. As with the first law of motion, you should consider the second law in 2 parts. The first part explains how the acceleration of an object depends on the force that it is being applied. Imagine that you give a push to the ball on the tee. Of course, you will make it move. But what happens if exerting the same amount of force you hit a truck? Of course it won't move because it has a greater mass than the golf ball. It exists an inverse relationship between the mass of an object and the acceleration that it may reach, because the bigger the object is, the more difficult it will be to accelerate. It's not the same effect if you push a bicycle with all your strength than if you push a car. The differences are easy to observe. The relationship between acceleration and mass and the force can be mathematically expressed by a formula. F is equal to mass times the acceleration, on which F represents the force, M represents mass, and A represents acceleration. And now the last one. Newton's third law of motion states the following. Whenever an object exerts a force on a second object, the second object exerts an equal and opposite force on the first. In other words, for every action there is an equal and opposite reaction. The action and reaction forces can also be experienced when you walk. With every step, you exert a certain amount of force on the floor. And of course, the floor exerts the same amount of force on you. Because of that reason, we are able to move forward or upward with the aid of the floor. Well, thank you very much for your attention. I hope this explanation was useful for you. I'll see you next time.